hopefully we went okay with G. I'm going to just begin with a little bit of H, come around and see how we went with G, and then address some common questions we had. I understand G was quite challenging, okay, some of it. So we have seen these angle sum and difference identities before, but again, just we're escalating the complexity. So I've written them all down here. They're the identities that we're going to be using, and we're going to look for ways to simplify and some relationship with what we see. So what we can see here, right, you know, this is an angle, this is some angle. It's written in this form, isn't it? It's cos A, cos B, plus sine A, sine B, okay? 3x plus 2 is angle A, here and over here, and 4 is angle B, here and over here. And so then we're going to look at our angle identities and go, which one does that resemble? And we can see it resembles the second one. It resembles cos A, cos B, plus sine A, sine B. And so that simplifies to cos of A take B. Okay, we can see from the top of where our rules are, that simplifies to that. So if A is 3x plus 2, then this is going to simplify to cos of 3x plus 2, okay, cos of A, that's angle A, take away angle B, which is 4. So we've got 3x plus 2 take 4, that's cos of 3x take 2. Okay? So that's something that we have had a bit of exposure to before. What we're going to do over here, we've got not only the complex skill, but we're combining lots of different things that we've done together. We're asked here to find tan of A plus B. Okay? So we are going to use the tan of A plus B formula, but before we can do that, if we look at the tan of A plus B formula, it is, I'm going to write it up here because we're going to need it. Tan A plus tan B on 1 take tan A times tan B. Okay, so if we want to find tan of A plus B, Brad, like it's asking, that means we need to find tan of A by itself and tan of B by itself. So if we look here, we've got sine A. Now in order to find tan is sine divided by cos. So we've got sine, that means we need to find the corresponding cosine value. So this is a process we've done ad infinitum. So we've got, like I'll make a long argument here, and then for the next one I'll do it fairly quickly. Okay, we know that sine squared A plus cos squared A is 1. Okay, we've got sine is 3 on 5. And we're going to rearrange this to get cos by itself. And then square root. Okay, so we started with sine A and we've rearranged, we've now got cos A. Cos A is positive 4 and 5, and it's positive because of the region in which it lies. It's restricted to the first quadrant. Okay, I'm going to repeat the same process with B, with cos B. Okay, so over here we've got cos B, that means we need to find sine of B. Okay, so we'll start with, I'm just going to do this one reasonably quick. We've got minus 23 squared plus sine squared of B. We'll rearrange it. 1 take 4 on 9, and we'll have sine of B is the square root of, what's that going to be, 5 on 9, which is plus or minus root 5 on 3. And it is in the third quadrant, so it's negative. Okay, so now that we've got both sine and cosine, we can state what tan is. Tan of A is sine of A on cos of A, which will be, what's sine
5 on top of 4 on 5, which is AD on BC, 3 on 4. Tan of B will be sine of B on cos of B, minus 2 on 3, sorry, minus root 5 on 3, on minus 2 on 3. Again, AD on BC, the negatives are going to cancel, and we'll be left with minus root 5 on 2.
Okay, so we have tan A, we've got tan B. Now you could do that using the process I've done here, okay, using the Pythagorean identity, or you could draw your right angle triangles and get tan A and tan B that way, okay. That might actually be a little bit shorter because then you don't have to do this fraction division. All right, so we've got tan A, we've got tan B. Now we're ready to find tan of A plus B. This is what it wants us to find, tan of A plus B. And so we're just going to use this formula over here. Tan of A plus B is going to be tan of A, which is 3 on 4, plus tan of B, which is minus 5 on root 2, on top of 1 take away tan A times tan B.
Mr. Ross, isn't it supposed to be a positive square root of 500? Because the two
Yes.
negatives cancel.
Thank you. Yep, absolutely. Good pick up.
Okay, and so that'll be our solution. And we could spend another 4 or 5 lines rearranging that to get a rational denominator, using the surd operations that we're learning in methods at the moment. And of course, the other option would be to put it in your calculator, in which you would put it out in the simplest form as well. Okay, but the point is, we've performed that process and we've got an answer here. Do you guys want me to keep going with it, or are we happy to leave it there? Nick's happy. Cool. So let's move on to 3, and we'll probably stop at 3 for a little bit, give you guys the opportunity to do something before they get too hectic. All right, so we've got 3. Now, so again, one of my typos, show that 2 sine squared, there's supposed to be a squared there, pi on 4 plus x equals 1 plus sine 2x. Okay, so I think you're just missing the squared there, is that correct? Yeah. Okay, so we, with this, there's a lot of these kind of questions in, if you've had a look at the practice test yet, maybe you're feeling adventurous, you've clicked on them, there's a lot of these kind of questions. It gives you this and to show that this will equal this. Okay, so when we're doing that, we need to start with the left-hand side grade, we need to manipulate it until it's equal to the right-hand side. So, so what we're going to do here, we're going to start with the left-hand side. It's 2 sine squared of pi on 4 plus x. And in fact, I'm going to get you guys to recognize what that is. It's sine of pi on 4 plus x squared. Okay, so really that's what it means when we have the sine squared. And then you can recognize this is sine of a plus b. Sine of a plus b. So we're going to use the sine of a plus b identity to expand it. I'll write that up here. Sine of a plus b is sine a cos b plus cos a sine b. That's the identity that we're looking at. It's at the top of your page there. So, so we're going to just expand the part in brackets. The 2 is going to hang out here, and the squared's going to hang out here. So let's do that. We're going to have 2. We're going to have sine of pi on 4 cos of x plus cos of pi on 4 sine of x. Leave the squared there. Okay, we're going to look at our unit circle so we can simplify these. Sine of pi on 4, we've got it by itself so we can simplify it. Sine of pi on 4, you guys are starting to know it off by heart. What's sine of pi on 4? Root 2 on 2. Okay, pi on 4, 45 degrees. Both sine and cos have the same value. So we've got root 2 on 2, or 1 on root 2 to write us. Cos of x, and then the same over here. Cos of root 2 of pi on 4 is also root 2 on 2. Okay, now in terms of bed mass,
We would perform what's inside the brackets first. We cannot add those together. Then we're going to perform the exponent. So that means we're going to square it. And we're going to use the perfect square rule here to square this. So this 2 is still hanging out the front there. We're not going to move that in yet. This 2 is still hanging out. We're going to have a squared. So we've got a plus b squared. We're going to have a squared plus 2 times a times b plus b squared. So let's do that. We're going to have root 2 on 2 squared cos squared of x.
okay, that's going to be a squared.
Plus 2 times root 2 on 2 cos of x times root 2 on 2 sine of x plus root 2 on 2 squared sine squared of x. Okay. Let's keep the 2 out front just for a little bit longer. Root 2 on 2 squared. Okay, so the squared goes to both the top and the bottom. We're going to have 2 on top of 4, or half. We're going to have here half cos squared x, and at the end there half sine squared x.
Okay, and hopefully we're starting to see the solution, see the answer. Now 2, look here, look at all these things we're multiplying by one another. We've got 2 times root 2 on 2 times root 2 on 2 cos x sine x. So I'm just going to put the cos x sine x at the end, okay, because they're not changing. But this part we've got 2 times root 2 on 2 times root 2 on 2. Okay, so there's a bit going on there.
You could perform it in any way you wanted to. I think let's leave that 2 for now and let's perform this multiplication. That might be the clearest way to do it. So if we have root 2 times root 2 at the top, that becomes 2, and 2 times 2 at the bottom becomes 4. Okay, so these 2 brackets simplify to be that, and then we've got this 2 hanging out the front. 4 on 4, this simplifies to be 1. Okay, so then we've just got plus cos x sine x plus half sine squared x. Let's distribute the 2. So that means we're going to have cos squared x plus 2 cos x sine x plus sine squared x. Okay, maybe you can see it. Now cos squared x plus sine squared x. Look at that, cos squared x plus sine squared x. What's that equal? 1. Okay, so there's our 1. We've got cos squared x plus sine squared x. And then here we've got this 2 cos x sine x. Now we could write that, you can leave it like that and I recognise the identity. When we've written the identity, we've written it like this. 2 cos x sine x, they're the same thing. Okay, the order of multiplication is not going to matter. And this is the double angle identity for sine. That's what you've been learning yesterday. 2 sine x cos x equals sine 2x. Okay, which equals the right hand side. So look here, we started with the left hand side, expanded, manipulated, rearranged, and we've got what we have on the right hand side. Okay, I will pause there, give you an opportunity to get some H done before we come back and have a look at the harder ones.